During World Oceans Month, we are celebrating our love for the ocean and those who protect it. In our new series, StoriesXFuture Ocean Innovation, we tackle the question, how can emerging media, art, and tech help unlock positive impact? Take a deep dive with us. The ocean makes up 97% of the water on Earth, and over 3 billion people depend on its resources. More than half of the oxygen we breathe comes from the ocean, and coral reefs are home to around 30% of the ocean's biodiversity. But the ocean is in trouble, affected by the increase in greenhouse gases from human activities that lead to ocean acidification and coral bleaching from climate change. The good news is, there are solutions we can put in place to turn the tide. In this episode, we're joined by Dr. Elizabeth Bagley, Director of Drawdown Learn, a new initiative by Project Drawdown. Their mission is to engage and inspire broad public audiences of adults and youth and connect them to the science behind climate solutions. Today, Dr. Bagley is going to explain how greenhouse gases affect the ocean and discuss the amazing solutions, both nature-based and people-powered, that will help us reach drawdown. I'm so excited to be joined by Dr. Elizabeth Bagley, the Director of Drawdown Learn today. Elizabeth, how are you?
Hey, Kristen. It is so great to be with you today. Happy start of Oceans Month. What a great month to dive into talking about ocean solutions.
Yes, and we're so excited as well to be kicking it off with Project Drawdown, who really can help us to contextualize not just the challenges, but really bring us straight into the solutions about how we can all work together to actually make a difference with creating a more sustainable ocean. So Elizabeth, please, how did you start your journey into sustainability?
So I grew up far away from the ocean in western Wisconsin on a sheep farm where we raised sheep, we raised Scottish Highland cattle, and really noisy guinea fowl that you normally find in Africa. And, in that setting, with sheep, with cattle, with those guinea fowl, I really started to understand how systems work. And that was why I decided to study zoology and environmental science at the University of Wisconsin, so I could really start to see how when the sheep would eat the shorter grass, the cattle would eat the taller grass, and the guinea fowl would pick the ticks off of all of those. They're all working together. And I just got really excited about how systems work and how humans like us are impacting those systems, sometimes in problematic ways and other times in really fabulous ways.
And so how did you start your journey towards actually communicating about science and helping the general public unlock this same kind of moment that you did as a child?
Well, so in college, I really wanted to study science. I didn't want to study to be a teacher. And I kind of made that decision early on in school. I said, the classes I want to take are the science classes. So that's what I did. But I still had this real drive in me to teach. So I actually joined Teach for America and taught high school science in South Louisiana, which was a really different culture, really different place than rural Wisconsin where I'd grown up. And I learned so much from the students and the faculty in South Louisiana, just about how do we communicate about big problems that often seem really insurmountable, and how do we help people put solutions into action so that they can start to be a bigger part of the solution for things like climate change. So I taught in Louisiana, and then I went back to graduate school and really dove into studying educational psychology. So how do we talk to people to change behavior and to inspire them, as well as environmental science, because I wanted to still really understand the science, but also understand that communication piece, so that ultimately what my goal has been and continues to be is to meet people where they're at on their sustainability journeys and help them take that next step. So instead of me being this kind of overbearing, this is what you need to do, kind of righteous environmentalist, it's really a companion along the journey. We're all at different places on our journey, and we all just want to be heard, and we want to help. We just don't necessarily know what we need to do. So I want to be that companion along people's journey.
Well, please tell us about Project Drawdown, because I mean, I've been so excited about that whole project since I got the book and started reading it, because it started to make all of this complicated science really solutions based, which made it seem very achievable. And I love how you guys have been working on that.
I appreciate what you said about really making invisible concepts visible, right? Like, how do we take something like a carbon footprint and help people visualize and feel and really understand what it is? And that was some of the great work that we could do there. And with Project Drawdown, our mission really is to put climate solutions into place as quickly and equitably as possible all around the world. And so the focus on solutions just is core to what I believe in and what I want to do. And really using the science that our researchers have gathered over years of review, synthesizing those data and being able to tell stories and inspire people to put those solutions into action wherever they're at on their sustainability journey.
So can you tell us about the actual science behind climate change? I mean, why is this happening to us? What is global warming? You know, I find that often the kind of terms become so scientific that it's not accessible to the general public. So can you actually decode this for us?
So what we're dealing with when it comes to climate change is that we have a number of different gases. We call them greenhouse gases, but I'm going to use a different phrase. Really what those gases do is they trap heat. So they trap heat and they form a blanket around our Earth in our atmosphere. So that blanket is getting thicker and thicker. And imagine that you are putting more and more blankets on you as a human. You're going to get pretty hot, right? The problem with our atmosphere is that it can't take off the blankets, right? So the blanket just keeps getting thicker and thicker. And what that ends up doing is it ends up increasing the temperature both on land and in the ocean, which we'll dive into what that looks like. So there are some really specific sources of those gases. And I think it's important for us to know where those gases are coming from so that we can make sure that we can reduce those sources, right? So one of the main sources of those heat trapping gases is actually from burning fossil fuels, things like coal, oil, and natural gas. And so a great solution in that space is to what we call decarbonize and not use coal, oil, and natural gas, because when we combust that, when we burn it, it releases carbon dioxide, which then traps heat and heats up the planet. We also get a lot of carbon dioxide as well as methane from the ways that we grow our food. So our food, all of the land, the ways in which we use the land, the animals that we grow, there are lots of things, there are lots of heat trapping gases that come from that process. And that's actually usually a really surprising source for people. Not a lot of folks have thought about how food, agriculture, and land use are really important sources when it comes to greenhouse gas emissions, or those heat trapping gases. So we've got electricity, or kind of the fossil fuel burning. We've got food, agriculture, and land use. And then we've got these F gases in terms of another gas. We've got other things that come from industry. So things like our refrigerants that are in our air conditioners and our refrigerators, those gases are amazing at trapping heat because that's what they're supposed to do, right? Like they were put into our air conditioners and our refrigerators to keep either our food cold for the refrigerator or to keep us cold for the air conditioner. But those gases, when they're released into the atmosphere, they keep doing their job. And we don't want them to trap heat in our atmosphere. So those F gases actually are much better at the job of trapping heat than gases like carbon dioxide and methane. And so those gases kind of pack an outsized punch when it comes to climate change, because while they don't stay in the atmosphere as long as some of the other gases, they're really good and much more potent at trapping heat. So those are things we need to remember too. So I think about climate science, we really want to think about the sources, right? We want to think about where they're coming from. And so just to kind of help us think through that, maybe I'll tell you 5 sources in things that we see during our lives. So one source is our electricity, and that's kind of our burning of mostly natural gas and coal for our homes, right? Our homes, our businesses, so it's electricity. thinking about food, agriculture, and land use, that's where more of the other emissions come from as well, another source. Our buildings, so our buildings use a lot of electricity. There's also a lot of, we call it embodied carbon in our buildings. Cement, actually, making cement takes a lot of heat, which means it takes a lot, releases a lot of heat trapping gases as well. So we've got electricity, food, agriculture, land use, buildings, industry. We talked a little bit about those refrigerants, but there's a number of other things related to industry. And the last one is transportation. So the ways that we get around. So thinking about all of the different heat trapping gases that are released into the atmosphere and the ocean from our transportation. So in a nutshell, our climate is changing because of those sources, those 5 sources that we are releasing into the atmosphere.
And can you break down what that means? I mean, recently in the last 2 years, many activists and scientists have really helped us to understand a little bit better the 1.5 degrees of warming. Can you kind of contextualize where we are on that scale and what that actually means in terms of if we increase beyond that point and continue to put these greenhouse gases into the atmosphere?
So scientists for decades have been looking at different scenarios to say, okay, if we have, this amount of heat trapping gases, here's what will happen in terms of global mean temperatures across the Earth. And the 1.5 degrees Celsius is really a point at which we know that there will be some really tough impacts, and we already are seeing really tough impacts all over the world, unfortunately, related to the warming on our planet and the changing climate. And so the 1.5 and then the 2 degrees Celsius goals or targets are really put in place for all of us, especially our policymakers and those of us who elect our policymakers, to give us some goals and some targets to work towards, because beyond that, the world really becomes quite unrecognizable and uninhabitable for humans. So when people, this is something I think about a lot, when people say, like, especially around Earth Day, like, let's save the Earth. But what we really are trying to save is humans, right? And humankind, and the ways in which we have a very narrow threshold within which we can ultimately survive, in the ways in which we need to grow our food, are pretty specific. So we need to make sure that we reinvent the system. So the 5 sources I just mentioned, those are all systems that humans have created. We created the ways that we grow food, right? We created the ways that we heat our lives and cool our lives. We created the way that we build buildings and our transportation, and we can absolutely reinvent that. And that's what gives me so much hope when I think about, knowing that we're going towards 1.5 or 2 degrees Celsius over the next decades. How can we put changes in place to reinvent those systems so that we don't get to those thresholds or go beyond them?
So you've described so eloquently, how greenhouse gases are affecting the atmosphere and how that's, baking the Earth in this shell of sorts. But how is that actually affecting the ocean specifically?
So I'm going to talk about 2 main ways that the heat trapping gases directly impact the ocean. So one of the things that's important to know is that from all the gases that are released into the atmosphere and kind of create that heat trapping blanket, depending on the sources you use, about 17% of those gases are actually absorbed by the ocean. And what that thick blanket does is actually warm the land and the ocean's surface, because we're getting warmer. And what that does to the ocean is increase the temperature of the water. And the organisms that have evolved to live and to thrive in the ocean have pretty narrow temperature bands that they can exist and thrive within. So what we see is really, really tough impacts like coral bleaching, right? Where corals, these incredible animals that have a symbiotic relationship with algae, then the algae give them color. When it gets too hot, the algae are like, I'm out. I can't do this anymore. And so the coral's like, okay, bye algae. And the coral is just waiting for the conditions to improve. And if they do improve, and what I mean by improve is if the temperature comes within range where it's habitable for the corals, then the the algae can come back and the coral can thrive again. But unfortunately, what we're seeing in a lot of places around the world is that the conditions aren't improving and the coral are bleaching and ultimately dying. Not all of the gases that are released in the atmosphere stay in the atmosphere. Some of it is absorbed by the land and some is absorbed by the ocean. And the carbon dioxide that's absorbed in the ocean through some chemical reactions actually ends up making life really difficult for organisms like shellfish and coral. They can't build the shells and the exoskeletons that they need as strong as they need them to be. And so that's called ocean acidification. And that's coming from, dissolving carbon dioxide in seawater. And that's because we've got too much. And the ocean is doing something that we call a sink. A sink is where it's taking the carbon dioxide and it's actually sinking it into the ocean, and it's becoming part of photosynthesis for organisms like kelp. It's also sinking to the ocean floor and becoming part of the sediment, but there's actually just too much. There's too much of it in the ocean. And so these chemical reactions are now they're now impacting shellfish and coral and things like crabs and other organisms that build shells.
So that's some of the direct problems on the ocean, but can you also describe some of the indirect problems that end up kind of coming after those points?
So we talked a little bit about kind of food, agriculture, and land use, right? And one of the kind of possibly surprising impacts on the ocean is the amount of fertilizer that runs off from the land, from our agricultural fields, into rivers and then into the ocean, right? So what's kind of a big bummer about all of that is that the farmers spent money on the fertilizer, right? But a lot of it is getting run off and into ecosystems that really don't need the fertilizer. And what ends up happening is that fertilizer is meant to help things grow, and it does a great job of doing that, and it does a great job of that in the ocean, which causes things like algae blooms, right? And really throwing off the chemistry and the larger biology and the ecosystem dynamics of the ocean. So that's one impact where if we were being a bit more precise with our fertilizer applications, we would reduce the amount of gases, of heat trapping gases that were released from that process, as well as reduce the amount of algal blooms and other things in the ocean. So that's actually a pretty powerful solution that we can think about. Like, how can we be more thoughtful and precise with agriculture? Because that helps a lot of different things. We also can think about overfishing. So what's happening, kind of as an indirect impact, is that some fish species are struggling more and more with changing ocean temperatures. One of the solutions is to think through marine protected areas and figure out how we can protect parts of the ocean. Now, we can't protect parts of the ocean from warming right now, right? Like, that's something where we have to reduce the sources, but we can really try to provide the habitats that the fish need so that they're not getting impacted from multiple different angles, right? So they're maybe having to deal with the ocean temperature, but not as much with habitat destruction and overfishing. So we're also seeing stronger storms that are lasting longer and maybe not coming within the traditional or historical hurricane season. And we know that that's happening because the surface temperature of the ocean and the surface temperature of the land is increasing. And so that's another impact that we're seeing because of the increased heat trapping gases that are enveloping kind of our whole planet.
I've read that there's also a lot of problems with not getting enough rain or not getting the proper amount of rain in areas. So the traditional actual weather patterns are changing. And you live in California. I mean, you've seen firsthand the wildfires and how that's spread across the state. So it's really just throwing everything off, isn't it?
There's a lot of imbalance at the moment. And I mean, going back to kind of the ocean, and we have natural protection from storms. Things in the tropics like mangroves and corals are incredible buffers for the strong winds that come in from storms. And as those start to decline and those ecosystems start to struggle, then the protection that they once provided is no longer there for the people and all of the other organisms that relied on that at one point.
Well, we're here to paint that bleak picture a little bit, more rainbow colored. We're not here to talk about all the bad things. And you've already started to touch on the solutions. And what I love about them is that, humans have been one of the major drivers of this climate change and as well as global warming. But we can also be one of the key solutions if we work together. And so can you please go into more of the details about, how Project Drawdown is advocating for this all to actually happen?
Absolutely. So, Kristen, I think just to reiterate, is it too late to take action on climate? No, not at all. We have so many solutions at hand. We don't need to wait for any fancy technologies. We can put solutions into place today. And actually, in our latest publication, which is on our website at drawdown.org, we have two different scenarios of what kind of solutions do we need to put in place and how quickly to make sure we stay below the 1.5 degrees Celsius threshold, as well as the 2 degrees Celsius threshold. So I invite folks to check that out on drawdown.org. And I'll tell you about some of the high points here, which is basically that we think about the 3 S's when it comes to solutions. So the first one we've talked about a bit, which are the sources. The first S is sources. We want to reduce those, right? So anything we can do to reduce sources, and we've got really robust literature and suggestions on our website to encourage and invite people to help reduce the sources. Just as an example of reducing sources, that's where something like reducing food waste is actually an incredible climate solution, often really surprising. But all of the heat trapping gases that are released in agriculture are wasted if we don't eat the food that was a result of that farming. So by really making sure that we are thoughtful about not wasting food, we can, that's an incredible climate solution that all of us can think about every day, multiple times a day. So that's one way to reduce sources. The second S is sinks. So thinking about how can we really support the natural sinks that this planet has had in place for loads of years, right? So how can we make sure that the soil is healthy so that the soil can absorb carbon as part of photosynthesis, right? So the plants, all of our plants, as we breathe out carbon dioxide, they breathe it in, or they don't breathe it in, but they absorb it. So let's support sinks, and we can do that on land. We can also do that in the ocean. And that's where a lot of really exciting research is coming out around kelp bed restoration and other research where the ocean can become this powerful sink for getting some of the heat trapping gases out of the atmosphere. So we've got reduce sources, support sinks, and the last one is to improve society. So by really working together across the world to make sure that we improve health and education for everyone, we can help. That's a climate solution. We can help people put solutions into action. Reduce sources, support sinks, and improve society. And one thing I want us to think about is that it's really impossible to separate the blue in the ocean from the green on the land. They and we are fundamentally intertwined.
And do you have like a really great example of you working in your whole life, where you've seen like this actual interconnection at play?
I do. And I was really fortunate in my junior year of college to study abroad in Kenya. And as part of that experience, I worked with the Worldwide Fund for Nature and the Kenya Wildlife Service on the coast of Kenya, where I was monitoring sea turtle nesting sites, studying fishing practices, and I had the opportunity to teach 7th grade science. And one of the days that I was with the 7th grade youth, we were looking at the ocean and we noticed that it was really murky. And we weren't really sure what was causing that murkiness. Now, we had been cutting down mangroves to use for firewood to cook. And that was just something, that was how we cooked food. And so we knew that there were fewer mangroves, but it was much more murky than we were used to. And I had just come back from the winter holiday where I was fortunate enough to climb Mount Kenya. And when I was climbing Mount Kenya, I, was looking around and noticing that people live on the slopes of Mount Kenya, and like the community I lived in on the Indian Ocean, they were cutting down trees to cook in their homes. And what was happening was that when the monsoon rains came and really hit Mount Kenya, because so many of the trees were gone, the soil would wash off into the river and then dump right into the community where I was living. And so what I realized in that moment on the shores of the Indian Ocean with those youth was that upstream actions by other people who were trying to do their best were impacting the folks downstream who were also trying to do their best. And that was a moment that and really solidified in me this importance of understanding complex systems and really looking kind of beyond just our communities. I mean, looking within our communities for solutions, but also being able to step back and see the bigger picture and the bigger system and understand how we might make that system, more equitable and healthier for both people and the planet so we could all thrive together.
So you've given us so much great background. You've given us the 3 solutions, cut out the source. What's the second one? Sinks. And the third one is society. As a mother and as someone who has really concentrated on trying to make all this stuff accessible and trying to create solutions for the next generation, what would be the closing message that you have for people who are starting to learn about this and who care about this? Where do they start their journey in order to really help people, scientists, to help the society around them to actually make this a better future for all of us?
I think it's important for us all to remember that we're all on different journeys, but we're all on this incredible planet together, and to find the solutions that you can put in place in your life, in your community, and really stick with it and inspire other people. Katherine Hayhoe has this great saying where she says, the most important thing we can do related to climate change is start talking about it. So thank you, Kristen, for spending time talking about it today, because if we're not talking about it, it's not top of mind for us. Actually, Kristen, this is some really interesting research that GlobeScan conducted with 14,000 people around the world. They asked the question, what do you think of when you hear climate change and global warming? And 40-something% of people thought of the outcomes, like the really bad stuff that we see on the news, that we read about in the papers. And only 3% of people mentioned solutions. And that's where I think we really have an obligation to change the narrative and start to think about solutions and put them into action. Because if we're not even thinking about them, we're not doing them. So, as a mother, I think a lot about how can we, work as a community to implement solutions. With my sons, we talk about why we do certain things we do. We have these through our energy company. We have specific things called ohm hours where they ask us to reduce our load, and so we turn off major electronics. My boys don't really like that because that means that we're not necessarily playing video games or doing other things, but we've ended up using that to our advantage and going on hikes or doing, playing a board game. And so really thinking about how we can start to think about solutions and put them into action. Because as I mentioned before, Kristen, the future is ours to write. And that's what is so inspiring to me. Like, we created all of those systems, many of which need to be reinvented, and we can do that. We are the people who are going to write the next chapter of life on Earth. So let's do it. Like, let's roll up our sleeves and let's be stubbornly optimistic and start putting those solutions into place all over the world.
So what's next for you at Drawdown Learn?
I am super grateful that at Project Drawdown, we really are we're scaling up and able to focus more on how can we support communities, how can we support faith groups, how can we support other organizations who want to put solutions into action. So what's next for me is actually finding partnerships where we can think maybe differently, maybe in a similar way about what solutions look like on the ground. I'm working with school districts. I'm working with faith communities. I'm working with community organizations to really get climate solutions into action in local communities. Because like I said, I'm not the person who should tell them what to do. I'm the person who can listen and empower them with the science, empower them with the stories that will inspire them to put the solutions into action in their communities.
Well, thank you so much, Elizabeth. We really need to have this blueprint, as you were saying, to actually understand that these solutions are possible and to really get us all, communicating about them, but also working together as a community to solve them. So thank you for all of your life's hard work, for really, dedicating it to creating a better future, and for taking the time to speak with us today.
Oh, it's my pleasure. Thanks so much, Kristen.